Today we're going to look at graphing quadratic equations, but instead of being y equals, we're going to be in x equals form. Our vertex form in this case is going to be x equals a times the quantity y minus k, quantity squared, plus h. This time our y is going to be squared, not the x. So let's look at just the most basic of examples, x equals y squared to start with. So if I were to go ahead and graph this function, notice we do have a quadratic because we have that squared term, but we're in x equals y squared this time. So instead of our graph opening up or down, we're going to see it opening left or right. So in this case, our vertex is going to be at 0, 0, just like it would be if it was at x squared. But now, instead of going up 1 and over 1 in both directions, left and right, and drawing a upwards parabola, we're going to come sideways. So we're going to come over, since we're positive a value, we're going to open toward the positive numbers. We're going to come over 1 and up 1, and over 1 and down 1. So our parabola is going to open up sideways. To look at our domain and our range, our domain, now notice over here at negative infinity, we cannot go up or down and touch the graph, but we can once we hit 0 and then go to infinity. So our domain starts at 0, we use the bracket to show that we can touch 0, and it ends at infinity. Our range in this case, we can come down here at negative infinity. Way out here we'll be able to touch this graph because this graph is going to continue forever and it's going to continually go down, and as we work our way up the y-axis we'll always be able to go over and touch that graph. So we say our range in this case is negative infinity to infinity. Let's go ahead and look at another example, this time giving you an a, k, and an h value. So let's say x equals 2 times the quantity y minus 3 and quantity squared plus 2. This is in vertex form, so we can find the vertex. Remembering now the vertex is going to be 2 because we switched our h and our k value, and it's going to be positive 3. Because we have a positive 3, we take the opposite of that negative, or what's with y. Our a value is going to be found outside the quantity, but multiplied to that quantity, so it's that 2. Notice it's a positive, so it's going to be opening toward the positives or to the right. So to graph this, we're going to start at the point 2, 3. Our a value is 2, so we're going to be able to come over 2 to the right, come down 1, and go up 1. Notice this is a little thinner than our previous example because we have that a value of 2. Our domain and our range. Our domain starts at 2. We don't have anything out here in the x values. So we start at 2 and we go to infinity. The range, we can come down here at negative infinity. We could continually go out. Since this continually drops, it's going to eventually come down to negative infinity. So our range is negative infinity. As we come up the y-axis, we'll always be able to go over and touch this graph. So as we come up to positive infinity, again, this graph is continually growing, so we'll be able to touch positive infinity. Again, we use the parentheses to say that we can't exactly touch that value. We use the bracket because we can touch that value. And that was example 2. In example 3, we're going to get a nice juicy problem. Let's look at 8x equals y squared plus 4y plus 28. Notice this is a rather ugly looking problem. We've got a number with the x, and it's not in vertex form. So what should we do? Let's go ahead and complete the square. We're going to leave the 8x alone. We're going to take our y squared plus 4y. We're going to leave a space plus 28. Completing the square, we're going to take that 4. We're going to divide it by 2, and we're going to square it. 4 divided by 2 is 2. Squared gives us 4. So we're going to add 4 to this right side. To combat that positive 4, we're going to subtract 4 from the 28. Factoring, we get the quantity of y plus 2 squared, remembering that 2 comes from what we got when we divided the 4 by 2. And then plus 24. Now we can take care of this 8 being multiplied to the x. Well, since 8's being multiplied to x, we can simply divide 8 on both sides. Remembering to divide 8 to both of our quantities or terms on the right side. So simplifying, we have x equals, there is an imaginary 1 out there that's understood. So we have 1/8 times y plus 2 squared plus 24 divided by 8 gives us 3. So now we're in vertex form. Our vertex is going to be 3, and then the opposite of what's with y, so -2. Our a value is going to be 1/8. Since we have a fractional a value, remember this is going to be a rather wide parabola. So we go to the point 3, -2, plot our point. Now what we can do is we can come over 1, and we're going to come up 8 and down 8. So without marking all those values out, it's going to look similar to this. Graphing it, notice we have a rather large and open parabola. For our domain and for our range, our domain, we're going to start at 3. So we say it's from 3 to infinity. In our range, we can have all of the numbers. So we have -infinity to infinity. Now we haven't talked about a negative a value, so let's quickly, in example 4, talk about a negative a value. And let's give it to you already in vertex form. So let's say -2 times y plus 3 squared plus 1. So in vertex form, it's going to give us our vertex as 1, opposite of 3 is -3. The a value is -2. So we can go ahead and graph. Our vertex was at 1, -3. Our a value is -2, so we know it's going to now open to the left. So here we can go over 2 to the left and up 1 to get to our next point. Opening to the left, there is our parabola. Now our domain and our range are going to slightly change. Our domain, notice now we can have these negative numbers. So we can start at -infinity, come down, and we'll touch the graph. As we work our way across, we'll be able to do that until we get to x equals 1. After 1, we will not be able to touch this graph. So we say our domain is -infinity to 1, including the 1. The range, again, is going to be -infinity, because we can come across and touch it way out here in the negatives, as well as up here in the positives. We'll always be able to come out here and touch the graph. Again, this is increasing forever. So our range is -infinity to infinity. So we should see a lot of similarities between the two forms. Remember, this now is in the form x equals a times y minus k squared plus h, instead of being the y equals form.